This video contains the solutions to the dot products practice problems handout. For the first few problems, we're dealing with these two vectors u and v, and the first one's asking us to compute u dot v. So if we want to do a dot product of two vectors, we simply multiply the x components, the y components, and if the vectors have them, the z components, and we add together the results with those products. So this is just going to be negative 10 times 1, plus 0 times 2, plus 4 times 3. That's negative 10 plus 0 plus 12, which works out to be 2. Next up, we need to find the angle between u and v, and this relies on a property of dot product, which is that the dot product of two vectors is equal to the length of the two vectors multiplied together, multiplied by the cosine of the angle between them. And we can figure out what all these values are. We already figured out that the dot product is 2. Now we just need to figure out the lengths of the two vectors. And the length of a vector is just the square root of the sum of the squares of its components. So negative 10 squared plus 0 squared plus 4 squared. That's going to be the square root of 116. And then the magnitude of v is similarly the square root of 1 squared plus 2 squared plus 3 squared. That's going to be the square root of 14. And so that means that we've got 2 equaling the square root of 116 times the square root of 14 times the cosine of theta. And so now we just want theta. So the cosine of theta is going to be 2 divided by the square root of 116 times the square root of 14. And so theta is going to be the inverse cosine of 2 divided by the square root of 116 times the square root of 14. We can throw that into our graphing calculator or into Mathematica, and we'll get that this is approximately equal to 1.52115. Now, by default, Mathematica and our calculator should be set to radians, and so this is a number of radians. But the question asks us to round our answer to the nearest tenth of a degree, which means we need to convert radians into degrees. We do that by multiplying by 180 divided by pi. That works out to be approximately 87.1553. And since we're asked to round to the nearest tenth, that means we've got 87.2 degrees. And that's the angle. One last question with these two vectors is to compute the projection onto u of v. And as I've said in class, that's how we want to read this. So that's going to help us remember how this works. It's the projection onto u, which means the vector that we're looking for is a scalar multiple of u. So that helps us remember that the formula is some scalar times u. Now we're going to divide by u dot u, and then the numerator here is going to be v dot u. So if we remember that formula, that's one way that we can remember to get this all straight. Now we've actually already computed most of this stuff. We know that u dot u is the length of u squared, and we know that the length of u was the square root of 116, so u dot u is 116. V dot u is the same as u dot v, which we already figured out was 2, and u is just the vector negative 10, 0, 4. 2 over 116, that's the same as 1 over 58, and so this is going to be negative 10 over 58, 0, 4 over 58, and those fractions reduce, so we get negative 5 over 29, 0, 2 over 29, and that's our projection. Now we've got a multiple choice question, so for any vector w, which of the following best describes the projection onto w of w? Well, we can use the formula here, and the formula would tell us that this is w dot w divided by w dot w multiplied by w. But whatever w is, that fraction equals 1. So this is just 1 times w, which is just the vector w, and so the correct answer is B. Finally, we've got a question about work. So when we have a force and a direction and a distance vector, the work is defined to be the force vector dotted with the distance vector. In this case, we've got our suitcase. It is traveling a distance of 50 feet horizontally, which means the distance vector is a vector that has positive 50 as its x component and 0 as its y component. And then the force makes a 30-degree angle with the horizontal, and the force is 30 pounds. And that means that using trigonometry, our force vector is simply 30 times the cosine of 30 degrees, comma, 30 times the sine of 30 degrees. That's going to be 15 radical 3, comma 15. So that means that the work is the force vector, 15 radical 3, comma 15, dotted with the distance vector, 50, 0, and that's just going to be 750 times the square root of 3, and the units here are foot-pounds.